Alright, in this video I'm going to do another example of solving a quadratic inequality. So in this case we have 2x squared less than negative 4x plus 6. What I'm going to do first is I'm going to make one side equal to 0. And the way I'm going to do that is I'm going to add 4x to both sides. So that's simply going to bring that over as a positive 4x. And then I'm going to subtract 6 from both sides. So that'll give me a negative 6 on the left. We'll be left with just 0 on the right side. To make the numbers a little bit easier, I notice that all of these are even. So I'm just going to divide everything by 2. So 2x squared over 2 is going to be positive x squared. Positive 4 over 2 is just going to be positive 2x. And then negative 6 over 2 is going to be negative 3. 0 over 2 is just 0. And at this point what I do is I solve the corresponding quadratic equation. Okay, I have to keep in mind, of course, that this is the inequality ultimately I'm trying to satisfy. But to do it, again, the process is I'm going to try to find solutions to the corresponding equation. And this one's nice because it factors pretty easily. I think we can factor this using, an x plus 3 and x minus 1. Again, those two numbers multiply to negative 3 but add up to positive 2. If we set each factor equal to 0, we'll have x plus 3 equals 0, so that'll give us x equals negative 3. And if we set x minus 1 equal to 0, if we add 1, we'll get x equals positive 1 as our other solution to the equation. So those certainly aren't the answers, but what we do now with these numbers is we take them and we put them on our number line. So I'm going to put negative 3 down there, and I'm going to put positive 1 down there. And again, all I'm trying to do is I'm trying to satisfy, again, this inequality. Okay, so this is the one that's important. And what I'm going to do is I'm going to plug negative 3 in, see if it works. I'm going to plug positive 1 in, see if it works. I'm going to take a number smaller than negative 3. I'm going to take a number in between, and I'm going to take a number bigger than 1. Notice if you plug negative 3 onto the left side, that's just going to give us 0 out. I mean, that's what we did here with all of our algebra, was figuring out what does make the left side equal 0. Since 0 is not less than 0, I'm going to put an open circle at negative 3. For the same reason, if you plug in 1, we'll get 0 on the left. And 0 is not less than 0. It is equal, but it's certainly not less than it. And again, now what we have to do is we just have to pick any number less than negative 3. Maybe I'll use negative 4. Any number in between negative 3 and 1, I usually use 0 because that just makes the arithmetic easy. And then any number bigger than 1. So maybe I'll use x equals, 2. Again, what I have to do is plug those into the inequality and simply see if they work or not. So let's see here. If we test x equals negative 4, so I would have negative 4 quantity squared plus 2 times negative 4 less than 3. And again, I'm asking myself, is that less than 0? So negative 4 times negative 4 is positive 16. Positive 2 times negative 4 is negative 8. Minus 3, and again, I'm asking myself, is that less than 0? Well, 16 minus 8 is 8. 8 minus 3 is 5. And 5 is certainly not less than 0. So that means negative 4 is not a solution, and what that means is no number smaller than negative 3 will actually satisfy this inequality. Notice if we plug in 0, I would get 0 squared plus 2 times 0. All of that simply works out to be 0. I would be left with negative 3, and then I would ask myself, well, is negative 3 less than 0? And yeah, negative 3 is definitely less than 0. So what that means is every number inside of there will satisfy this inequality. And now I'm going to take something bigger than 1. Maybe, again, we picked the number 2 here. So if I plug in x equals 2, I'll get 2 squared plus 2 times 2 minus 3. And again, I'm asking myself, is that less than 0? Well, 2 squared is 4, plus another 4 is 8. 8 minus 3, I'm actually getting 5 again. And 5 is, again, not less than 0. So nothing bigger than 1 will satisfy this inequality either. So it says the solutions to the original inequality that we were trying to solve, again, the solutions to this inequality are the same as the solutions to the very original inequality. So in interval notation, it says we start at -3 but don't include it, so we use parentheses, and then go up to +1. Again, don't use it, so we use parentheses to indicate that that value is not a solution.